Okay, so today we're going to be talking about transcription, and unfortunately I can't draw, so we're just going to have to follow along with my mouse. So because DNA cannot leave the nucleus, and what goes out is just going to be a copy, which is basically transcription. So we're going to read from 3 to 5, so from here to here. And we're gonna start with this section because this is going to be the specific section that we're gonna take that's going to give the specific signal. So the promoter is gonna receive a signal, and then it's gonna lock on to the 3' end and find the gene it needs to make. So it locks on over here. It finds the TATA over here, the TATA box, and then it's going to move to the section over here where it's going to start reading and writing. So it latches onto the TATA box and it will break up the hydrogen bonds and become an open complex, which is right here. The hydrogen bonds are broken up. As you can see, they're not attached anymore. And then we are going to need the code that codes for the protein we want. As I said, it's going to be to this specific section for that specific code. So we start reading and writing from 3 to 5N right here in this specific section. And then we're going to get the anti-parallel, or the anti-parallel is from the 5 to 3N, just this way, from 5 to 3. And then we're going to stop. The codon is where it stops and it ends. So after this is done reading and writing from the 3 to the 5, we're going to end up with this code from the 5 to 3N right here, this red thing. And then it's going to stop right here, which is the stop codon. And that's where it stops reading and writing. Now we have a pre-mRNA strand, which is this red strand right here. Then the DNA, which is this, our regular blue DNA, has to stay inside the nucleus, but it needs to code, or the code needs to get out, which is our RNA strand, and needs to go to a ribosome. So in order for our pre-mRNA strand to leave the nucleus, we have to put a 5 cap on the top right here where the 5 strand starts. So basically a cap is put onto the top of the pre-mRNA strand at the 5, because when it needs to leave the nucleus, it needs to break out whatever is in its way without harming the pre-mRNA strand. And then at the end, which is at our 3N right here, because it's very fragile, we want to put a poly-A tail, which is more nitrogen bases that are going to be attached at the end that don't matter or mess up the code. So when it does leave the nucleus, if something cuts off those extra nitrogen bases, it won't break the code, and those nitrogen bases don't matter. Those are actually, their job is to get broken off so the code doesn't get messed up. So most of the pre-mRNA, the red strand, is important. However, there are some parts of it that don't necessarily code for the exact code that we want. So those are called introns. So this section right here could matter, and this probably doesn't. So this would be our intron, and this would be our extron, because the extron matters. So we will go through a system called splicing. A process that's called splicing is to remove the intron parts and replace them with the extrons, so the whole pre-mRNA code is the exact code that we need for that exact signal. So after we're done splicing, the pre-mRNA strand is exactly how we want it to be and is ready to leave the nucleus. And when the pre-mRNA strand does leave the nucleus, it is no longer a pre-mRNA strand, it is only an mRNA strand.